Okay, so this is the next lesson in geometry. It's called Proving Angle Relationships. The last lesson was focused solely on proving segment relationships, and this lesson is going to be proving angle relationships. So, first thing I want to recall is I want you to recall the angle, I had a typo, the angle addition postulate from the first unit. We're going to be using that as a reason in some proofs moving forwards. Okay, so here's the angle addition postulate. It says if point R is in the interior of angle PQS, then the measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS. And the converse is also true. So basically, if you add up all the small angles, it equals the entire angle. That's the angle addition postulate. We're going to be using that in some proofs. Okay? So here's example 1. Complete this proof. Given the measure of angle DEF equals 48 degrees and the measure of angle DEG equals 115 degrees, prove that the measure of angle FEG equals 67 degrees. Okay, so statement 1 will be my two givens. Reason 1 will be given. For statement 2, I am going to use the angle addition postulate. I am going to say that the measure of angle DEF, that small angle, plus the measure of angle FEG, this other semi-small angle, equals the measure of the entire angle, which is the measure of angle DEG. And again, that is the angle addition postulate. Okay, now the next step, I'm going to substitute. I'm going to say, instead of the measure of angle DEF, I'm going to say 48 plus the measure of angle FEG. We don't know that, so plus the measure of angle FEG equals the measure of angle DEG, which is 115. You can put the degree symbols. If you forget them, it's okay. And again, that's called the substitution property. And now we can get the measure of angle FEG equals 67 degrees by using the subtraction property of equality. Subtraction, POE, property of equality. Okay, now page 2 in this lesson has no writing. I'm just going to go over some theorems, okay? This is called the Supplement Theorem. Let me just look at one thing that I posted on Classroom. You may also hear this referred to as the linear pair theorem. And I believe that's what I referred to on Classroom, and I think it sounds better that way. It says if two angles form a linear pair, then they are supplementary. Okay? I refer to that, I call that the linear pair theorem on Classroom. So I'm just going to write it down right here, aka the linear pair theorem. This next one is called the Complement Theorem. If the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. So you have two adjacent angles, 1 and 2. If the non-common sides, which is this one right here, and this one right here, if they form a right angle, then the angles are complementary. They add to 90. Okay. These next two theorems, I believe we've mentioned in the past, maybe not in too much detail, but angles supplementary to the same angle or two congruent angles are congruent. Okay? So I refer to that on Classroom as the congruent supplements theorem. So I'll put that right here. That's called the Congruent Supplements Theorem. Think about it. If we have an angle, let's say angle 2 is 100 degrees. Let's just make it easy. Let's say angle 2 is 100 degrees. And I say 1 is supplementary to angle 2. So I'm just going to write this down. If we pretend that angle 2 is 100 degrees, just to make it easy, and I say angle 1 is supplementary to it, then that means angle 1 has to be 80 degrees. And if I say angle 3 is also supplementary to angle 2, that means angle 3 has to be 80. So you see these are the same, because if they're supplementary to the same angle, they have to be congruent. Same thing with right angles. So this is called the Congruent Complements Theorem. I called it that on Classroom. So if we pretend, let's just pretend that angle 2, just to make it easy, let's say it's 70 degrees. If I say angle 1 is complementary to it, then angle 1 has to be 20. This 20 plus 70 is 90. And if I say angle 3 is also complementary to angle 2, then angle 3 has to be 20. So you'll see 3 and 1 are the same. They're each 20 degrees. That's the Congruent Complements Theorem. And the one above is the Congruent Supplements Theorem. Okay? It makes sense when you think about it. Okay, on to the next page. Let's see, we have one proof on this page, and then one problem that's not a proof. Whoa, that's crazy. Okay. So for this problem, okay, we're going to prove that theorem that I just gave you. We're going to prove that theorem. Okay? We're going to prove it. So we are proving the, let's see, we're proving the Congruent Complements Theorem. So we have to do this proof without using that in the proof. I want to prove that theorem is true. So let's go and do that. So we're given two pieces of information. We're going to put that in both in statement 1. So angle 1 and angle 3 are complementary. And angle 2 and angle 3 are complementary. Reason 1 is given. We want to prove that angle 1 is congruent to angle 2. Okay? So here's how I'm going to do that. If 1 and 3 are complementary, then it means that the measure of angle 1 plus the measure of angle 3 has to equal 90 degrees. And if 2 and 3 are complementary, so I'll say and, the measure of angle 2 plus the measure of angle 3 has to equal 90. So that is called, well, that's the definition of complementary angles. If you're ever not sure what the reason is, or if you're not sure if it's a property or a theorem, and you're just taking a guess, just put definition of something, but this is called the definition of complementary angles. They're complementary, so they add to 90. Now I'm going to use the substitution property. It tells me use the substitution property. If the measure of angle 1 plus the measure of angle 3 equals 90, and the measure of angle 2 plus the measure of angle 3 equals 90, then I can say that the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Okay. Okay, not so bad so far. Now this next step, some people don't put it, and I'm not that crazy about it myself, but some places do require you to put this. So it says use the reflexive property of equality. The reflexive property of equality means you can say something equals itself. So I can say that the measure of angle 3 equals the measure of angle 3. Now I'm not crazy about this step, and If you don't put it, I think I'd be okay with that because I might not put that myself when I do these problems. But some places do require you to put that. Because now we're going to use the subtraction property of equality, and I'm going to say that the measure of angle 1 equals the measure of angle 2 because I'm subtracting 3 on each side from step 3. So that's called the subtraction property of equality. So some places, some textbooks will require you to do step 4, and some won't. So I included it here because sometimes your textbook does. But now, since I have that the measures of the angles are equal, I can say that the angles are congruent. So I can say that angle 1 is congruent to angle 2. Now, whenever you have two angles are congruent and you want to say that the measures are equal or vice versa, it's the same thing as with segments. Whereas for segments, I said definition of congruent segments. Now I'm going to say definition of congruent angles. So you use that statement, that reason, whenever you have two measures of angles being equal and you want to say that they're congruent or vice versa. If you know two angles are congruent and you want to say the measures are equal, you can call that definition of congruent angles or definition of angle congruence, either one. Okay. This next theorem is called the vertical angles theorem, and I think I told you this before. I believe we did. Yeah, we did that. If two angles are vertical angles, then they are congruent. That's called the vertical angles theorem. Okay. So, for example, angle 1 and angle 3 are vertical angles, so it means that they're congruent. Angle 1 is congruent to angle 3. And angle 2 and angle 4 are vertical angles, so they are congruent. Angle 2 is congruent to angle 4. Remember, vertical angles are two angles whose sides are opposite rays. So now we have a problem that's not a proof. Oh boy, I forgot what it was like to do these. Anyway, given that angle 1 and angle 2 are vertical angles, the measure of angle 1 equals x, the measure of angle 2 equals 228 minus 3x. Find x, find the measure of angle 1, and find the measure of angle 2. Okay, so since angle 1 and angle 2 are vertical angles, it means that they are congruent by the vertical angle theorem. So angle 1 is congruent to angle 2. That means that their measures are equal. So it means that the measure of angle 1 equals the measure of angle 2. So set them equal and solve. X equals 228 minus 3x. Let's solve that for x. So we'll add 3x to each side to get 4x equals 228. And then you're going to divide by 4. And you're going to get x equals 57. Now we can get the two angle measures. The measure of angle 1, well, the measure of angle 1 equals x, so that's easy. Measure of angle 1 equals x, so measure of angle 1 equals 57 degrees. Again, notice how I write that. Measure angle 1 equals 57 degrees. Don't forget that little m. And now the measure of angle 2, well, you should know it should be the same as the measure of angle 1, but let's just do it out just to be absolutely positive we got it right. So 228 minus 3x. So 228 minus 3 times 57. 3 times 57 is 171. (228 minus 171 gives you 57 degrees. Good. It's the same as the measure of angle 1. That's what should happen because they're vertical angles, so they're congruent. So their measures should be the same. Okay. Next problem. Example 4, back to proof, sadly. Given that angle 1 is congruent to angle 2, let's label that. Might as well. Prove that angle 1 is congruent to angle 3. Okay. Angle 1 is congruent to angle 2, given. Now, this next statement, usually you'll see this written in the vertical angle theorem proofs, okay? Whenever you have two vertical angles, before you use the vertical angle theorem, you really should say that angle 2 and angle 3 are vertical angles. And that is the definition of vertical angles, okay? So you really should say that in the vertical angle theorem proofs. You really should say first you have vertical angles, and then you can use the vertical angle theorem, and you can say that angle 2 is congruent to angle 3, because that is the vertical angle theorem. So since I have one arc on angle 2, I'll put one arc on angle 3. And now you can see angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So you can say that angle 1 is congruent to angle 3, and that is the transitive property of congruence. Okay, but you really should include step 2 and reason 2 in these proofs. You have to actually state you have vertical angles, then you can use the vertical angle theorem. Okay. Last one. RV bisects angle QRT and RT bisects angle VRS. I'm going to put both of those in statement 1. You can split them up into 2 boxes if you want, but then you're going to use 5 steps, and I only put 4 here, so I'm going to put them in 1. RT bisects angle QRT, and then ray, well, it should be RV right there, and then RT bisects angle VRS, and that was given to you. Okay, so if RV bisects angle QRT, that means that this angle right here is congruent to that angle right there. Because RV cuts it in half. So I'm going to say angle QRV is congruent to angle VRT. And in that same step, since RT bisects VRS, it means that this angle right here, VRT, is congruent to TRS. And since there's one arc on VRT, I'm going to put one arc on TRS. So I'm going to say, and angle VRT is congruent to angle TRS. And that is called the definition of an angle bisector. Okay? Because it doesn't, whenever it doesn't have a theorem name, or a postulate name, or a property name, then it's going to be a definition of something, and this is the definition of angle bisector. But check this out. Angle QRV is congruent to angle VRT, and angle VRT is congruent to angle TRS. So I can use the transitive property and say that angle QRV is congruent to angle TRS. Transitive property of congruence. And now, since I know the two angles are congruent, I can get to my statement I have to prove. I can say the measure of angle QRV equals the measure of angle TRS, and that is called the definition of congruent angles. Okay? And that is the end of that lesson. That lesson was just called Proving Angle Relationships.